In an earlier video, I've looked at collisions between two objects, or more specifically between two squares or two bounding boxes on objects. And it's a really useful way of finding out collisions, especially when two objects are moving or they're binding sprites or something like that. But against the background, that's not always the most sensible way to do things, because actually the background shape is quite irregular, and also it's got a lot of tiles on this background. You can see here my background is all over the place, and so to have some sort of specific function that knows where my background is and is able to calculate a collision is going to be really, really tricky. I could ask if the pixel underneath my character is a certain color and then make a decision based on that, but that also is a little bit restricting. My background would have to be the same sort of color, and it's just not going to work very well. So instead I'm going to rely on two really important code words called fget and mget. And I'm going to rely on the idea that although my object is located at a particular XY location on the screen, it also occupies a location based on the grid occupied by the background. And if you haven't watched it already, there's an earlier video that looks at calculating the grid position of an object based on its X and Y location. And so if you want a little bit of an idea of why some of the code in this video is the way it is, have a look at that earlier video just so you can get a good idea about what's going on, because I'm going to use the function floor, and I'm just going to use it without talking about it in a great deal. So if you want to know about that one, use the earlier video. So let me just reboot Pico-8 here, and we will look at putting together a platformer, or at least the beginnings of a platformer, based on two really, really useful functions. So let's run in. First thing we're going to need are some sprites. So I'm going to create a background. Let's make it basically grey with a nice edge to it like this. Okay, so those are my background tiles, and they're going to tile all over the game screen. I might actually just add a little bit of shadow on this side as well. Okay, so there's a background screen, and I'm going to have a little character that's going to move around the screen. Okay, and my character is going to look like this. Okay, there's my character. Okay, so I've got a background and a character, and I'm going to draw a map on here. Now remember, with the map, if you press the space bar, you can see the edges of the map there. I'm in the top corner of it. So we need to start drawing in the top corner to keep things simple. You can draw wherever you want, but if you draw elsewhere, you're going to have to think more, and who wants to think too much on this? Don't forget also, if you scroll vertically like this, these down here represent the bottom of the screen. So I'm going to put in a bottom level here, like that, of my grid. Okay, and then I'm going to build it in a sort of shape like that, maybe some more there, and then up here I'm going to put a couple of sort of floating islands, you know, the sort of thing, and then maybe up here a couple more bits of background. Okay, so there is my background, remembering at the moment that in terms of the map, this part here is at 0, 0. You can see it down at the bottom of the screen down here, 0, 0, and that's this bit up there. Okay, so let's go to some code and get some of this on the screen. So function draw, I'm going to clear the screen. Before I do anything else, I'm going to put an end in. I'm going to clear the screen, I'm going to draw the map, 0, 0, 0, 0, 16, 16. So hopefully you all know what's going on with that. And I'm also going to draw my sprite, and I'm going to draw it at an XY location, and it's sprite 2. Okay, making a bit of a hash of that, 2, X, Y, close brackets. That's all I want. And then just to make sure everything's running okay, I'm just going to have the X equals 63 and the Y equals 63. Okay, so if I press escape and type run, there's my object sitting there. Okay, and my background. Now let's have our next bit, which is going to be our function update. Okay, we'll put an end in, and I'm just going to do the usual sort of movement. So I'm going to say if btn naught, then x minus equals 1 end. I'm going to copy that and I'm just going to paste these in. Okay, so we got button 1, button 2, button 3. This one is incrementing x, this one is making y move, this one is also making y move, but in a positive direction. So if I now, my object can move around. Now this isn't very good platformer. I'd really want to implement some gravity to make things jump around, you know, so it always drop to the bottom of the screen. I'm not going to do that straight away, but you can see that my object can move anywhere on the screen and in fact through my background. So there's a few things I'm going to need to do here to make sure that this works. The first is I want to make sure I know where the object is in terms of the grid. Okay, so I need to ask grid x, and these are just for demonstration, by the way, the grid x and grid y. You'll see in a second when I start to actually program this that these aren't absolutely crucial, but it just helps to keep us in a frame of mind where we know what's going on. So grid x is equal to the floor of x over 8, okay, and grid y is equal to the floor of y over 8. And down here I'm just going to print grid x, comma, grid y, and I'll put it at say 5, 5 in white. Alright, so if that's not going to work, I've just realized I've missed some dots. If I run that, there's my grid location. Okay, so if I'm right up here, I'm in square 0, 0, and if I scroll down towards the bottom of the screen, I should end up at square 15, 15, which is the 16th square across. Okay, that's just useful for us to keep track of what's actually going on, but as I say, it's going to be a little bit more complicated than that. Really what I'm going to need is a function, and let's just have a little look at what this function is going to be doing. So I'm just going to have a simple grid system here, okay, and I'm only going to look at 4 squares. And in this square here, there's going to be something to collide into. Okay, so some sort of background that I don't want to hit. Okay, the other squares are fine to move through. So what's going to happen? Well, I'm going to take, again, the old bounding box idea. Let's say my object is just here. Okay, and I happen to know that this location here is the x, y location of my object. And my object will have, as always, a width and a height. What I want to do is I want to check every pixel across here and every pixel down there to see whether any of these collide with any object. Because if you imagine, if I'm moving in this direction, the x and the y are here, there's no point in just checking x and y. I need to check x and y plus the width, because if the width touches there, I know it's not going to work. Okay, so this is what I'm going to do. I'm going to check the location. I can make it quicker by checking the 4 corners, which is what I'm going to do. So I'm going to check the 4 corners, because in the end that's going to be a quick energy saving way of doing this. And I'm going to check, is this corner in touch with something? Is this one? Is this one? And is this one? So let's imagine this object here moving over to the left by a speed of, let's say, sp. Okay, so it's going to, in theory, end up here. So that is speed. I'm going to check this corner, this corner, this corner, and that corner. Okay, and that's going to tell me if there's a collision. Now what's going to happen is this is going to say yes, yes there is a collision, and it's going to prevent me from moving into the box. And I'm going to do that in all different directions. And by doing that, I can find out whether there's a collision with the background. So I have to basically know the grid reference. So this one here would be, if I look at just this left button here, although there's an x and a y value, the grid reference, if I count these, is 1, 0. Okay, and when I move to here, the grid reference is 0, 0. And my map on screen is drawn from the map section of Pico-8. And the map section of Pico-8 will have grid section 0, 0 coloured in with a tile, and grid section 1, 0 empty. And so when I move into grid section 0, 0, it will say there's a tile there. So there's a few bits and pieces I have to do to get that to work. So if I go back now to my code, what I can look at in here is this. These are flags, and I can set any of these flags that I would like. So I'm just going to set this first flag here. Okay, so flag 0 is going to be set as a 1, or on, true, sorry. Okay. That then means that all of these tiles here, which are all belonging to tile 1, will have a flag set to 1. So we're going to use a really useful function called mget and fget. I'm going to introduce two new variables. Map tile, which equals 0 to start with, and flag tile, which equals 0. And these are going to give me the values for the map and the flag at a particular location. So map tile is just equal to mget, and I just give it an x and a y location, and the x and the y is grid x, grid y. And down here I could print map tile at a location of, say, 5 across and 11 down. Okay, so if I run that, you can see I'm on tile 0, but if I come up here, tile 1, so it knows what the tile is underneath. Okay, so you can see tile 0, tile 1, tile 1, tile 1, tile 0. Remembering, of course, it's basing everything on that top left corner. If I go into my sprite and I just make sure that this one here is in bright yellow, that's what's triggering it. So as I go across, you can see tile 1. So we can see this is going to start to get useful. Let's now get the flag. Okay, so flag tile equals fget, and you have to just give it the map tile. So this is now going to give me the map. Oh, sorry, I'm going to need to print that as well, aren't I? So let's just grab this one, Control C, put it underneath flag tile, and I will put that another 7 down, so 17. So if I come this way now, you can see whenever I'm over a particular tile, you have that. Just to give you an idea of things, let's imagine I had some sort of lovely background idea that maybe looked a little bit like this, for whatever reason, and that square sometimes gets pasted around. Okay, so I'm just doing this, and it's just a sort of decorative style of thing, and isn't necessarily anything to do with the game. Okay, maybe it's just some sort of decoration like that. If I run this, you can see I'm over tile 3, over tile 0, but it's fine. They've all got a flag value of 0. But when I move over one of these, the flag is 1. So that's going to be really, really useful. And in fact, you can shorten this. You see where I've said map tile equals mget grid x grid y and flag tile equals fget map tile. Well, what I can do, I can get rid of the map tile variable. So we're not going to print that anymore. So this one's going to get printed up a bit. And instead, I can just say that the flag tile equals fget of mget grid x grid y. Okay, so I'll just get rid of this bit of code here as well. So now I'm just getting directly that one. So if I run it now, you can see nothing, 1, nothing, 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 1, and so on like that. Okay, and so sometimes you hear people talking about fget mget, and that's what they're talking about. You take the flag of the map of the grid reference. So that's how fget and mget work. But they're not really stopping us from moving at the moment. To stop us from moving, we're going to need to really wrap it all in a function. So I'm just going to write a function called hit, and it's going to take a couple of different things. It's going to take the x and the y location of the object, and it's going to take the width and the height of the object, and that's all I need to know. It's a function, so we want to close it, and the first thing I'm going to do is just set a variable called collide, and it's going to be false. And then I have to ask a couple of questions, and the questions are in the x and the y direction. I need to know, is there a collision in the x or is there a collision in the y? So I'm going to loop through the box. Now if you remember from just a little bit earlier, here's our object, this is the XY location, and I wanted to check there, there, and there. So how am I going to do it? Well, the easiest way to do it is to go, okay then, if I do a for loop, let's go x to x plus width, okay? But I don't want to move through every single tile, so I can just move by width, okay? So if you remember the for loop, you can set how much you want it to move each time, and I want it to move by a value of width. So it's only going to give me two values, x or x plus width. So that's what I'm going to do now. So in here, I'm just going to say for x equals, sorry, not for x, for I equals x, comma, x plus width, comma, width, do, and remember to close it, end. So what am I actually going to do in here? Well, I'm going to ask the question, if fget, mget, so in other words, if the location at I over 8, all right, comma, y over 8. So in other words, I'm checking for where it is and where it is with the width over 8. Okay. So if that flag is greater than 0, or, because I've got to be careful here, fget, mget, we want to do the same again, I over 8, but we're looking for the bottom, okay, down here. So down at the bottom, down at this point on my picture. So we want y plus h, which needs to be in brackets. So in other words, we're checking, sorry, I moved my mouse, y over h, y plus h over 8 is greater than 0. Then, okay. So what I've done is I've said, if the flag in the top left corner or the top right corner is greater than 0, or the flag in the bottom left corner or the bottom right corner is greater than 0, then, well then what? Well then we've hit something because we've got that flag. So collide equals true, and we can close that, end. Okay? So now we can go back to our movement over here. I've still got these values for grid X, grid Y, flag tile, just to show you what's going on. And we'll leave those in for the time being, but they're not crucial to the actual code itself. So the next question to ask is this. We want to move our object. Are we actually going to be able to move our object? Now what's happened here is in each instance, I've tried to move the object by a certain amount, okay? But there's a better way to look at this. I'm going to separate out the x and the y's, and I'm going to have a new value here, which is just going to be called dx, which is 0, and dy, which is 0. And if I press the button left, I'm setting dx to equal -1. In other words, I want it to move by -1, but I'm not yet moving it. And I want here dx to equal 1. And in this one here, I want dy to equal -1, and I want dx to equal, not dx, dy to equal +1. So this allows me effectively to preset how I want the move to happen. I'm saying here, if I press button 0, I want it to move to the left. And if I press button 3, I want it to move down the screen. In other words, I'm setting dy to 1. Because then what I can do is I can ask a simple question. If there is a hit in x plus dx, comma y, and then I have to give it the width and height of the box. You remember the hit function down here, x, y, width, height. So my box is going to be a 7 by 7. Okay, the reason it's 7 by 7 is down here I want to add a bit to it, but I want to stay within the box. Okay, we can fiddle around and have a look at these things. So if there is a hit, then we're not going to do anything. We're just going to set dx to equal 0. End. And then we need to ask the same in the other direction. So we need to say, okay then, what about in the y direction? So in this instance, we leave x as is, and we take y plus dy. Okay, and that gives us this one down here. And now we can say x plus equals dx and y plus equals dy. So now if we move, you can see, oh, no, you can't see because we've made a mistake somewhere. Let's have a look round. That looks okay. If we come down to our function, we have not returned the value. We've done all of that work and then we haven't bothered actually telling anyone what on earth's going on. Let's return, if I can spell it correctly, return collide. If we don't return the value of collide, then the function hit just returns false all the time, and it's just it returns, false all the time, which is pointless. We do actually want, having done all of this calculation, to return a value of true. So if hit set the speed to 0, if hit do the same. So let's now see if we run our code. You can see we just bash into things, so it's moving, bash, like that. And you can see there you've got a nice bit of collision detection that runs quite nicely. Now, there's a couple of things to realize with this fget mget. The first is, if your speed is higher, this very simple collision detection here won't work. You're going to need to loop through every single position that it's going to be in and check your collision from there. And that's quite an important one. And there's an earlier video, if you look at the collision detection using the hitbox ideas, then that talks about how to loop through. So I've kept the speed at 1 because it's very simple. The other thing to realize is this: if the location of your map tile moves here, then actually it matters a lot. Let me show you what I mean. Here I'm going to just come across a bit like this, okay, and I'm going to draw this all the way out to here. Alright, so here is a new background, okay, and my new background looks a bit like this, and I'll put some purple bits in as well. And I can draw that background, as you know, by just changing my positions here. So I want to draw instead the map that's at 16 naught. So if I run that, there's my new map at 16 naught. But if I move around, you can see I'm banging into things that exist elsewhere. Okay, it's not following what I expect. Here we go, I can come down, I'm stuck, I can't move sideways. Okay, and what it's doing, of course, is it's colliding with the original map. So on here, if I move, well, for example, I can't, when I start, because my if I start again, if I press run, I can't move down. If I change this back to 16 and run it, I can't move down. And it's because the location isn't relative to the screen. It's not what I can see on the screen. It's relative to the actual map over here. Okay, so this is what actually matters, this map. So if I've shifted by 16, I need some sort of value in here. So I would call it something like map x, which equals 16, and map y, which equals 0. Okay, and then down here I would draw my map at map x, map y. Okay, so that's drawn my map x and map y. And so my collision up here is very important. It's not just x and dx. So down in my fget mget function, I'm going to need to shift these plus map x plus map y. Okay, and down here plus map x, and this one is also plus map y. So now you can see I am actually colliding with my original. Now that's very poor programming because I have assumed that this value is global and I haven't passed it to the hit function. So maybe what I would do is actually in here I would pass it to two variables, map x, map y, and I would incorporate those into there so that the function is self-contained. But I just wanted to get across the idea to you that it's not the screen that matters, it's not what's on the screen, it's what's on the map. And if you are drawing a different map, you have to remember to offset the mget collision. Okay, so that's how to use mget and fget together to create collisions with the background. There's some complications involving the shifting of the map and varying different speeds, but the basic idea is the same. You can use these flags to work out collisions, and it's a really nice way of doing collisions. Happy programming.